running for this. Okay. A few semesters ago, I think one of the students gave this to me. I thought, yeah, that sums up a whole lot. It's sadly what happens. Case in point, my son Wes was running all of IT for a big construction company down in Texas. We're talking about a company that did a couple $100 million business a year. And he kept going back to his boss, who was the CFO, and saying, you know, I need more equipment, I've got this, I could use at least one staff person. And frankly, I could use a raise because they weren't paying him for what he was doing. And the CFO was like, nah, we're not going to give you any more money. We're not going to give you any staff, and so on. And he finally got frustrated and quit and went to another company, found another job. He did follow my rule, which is never quit your current job so you have a new job lined up. What he found out, because of people he knew there afterwards, is that they ended up replacing him with 6 people. And that the lead person they replaced him with, he was making, I think, around $60,000. The person they brought him to replace him, they paid $100,000 a year. Companies can be really stupid with regards to personnel. I've seen this in numerous situations. Okay, pitfalls. Technically, I'm writing a book called Pitfalls of Modern Software Engineering. I've made no real progress on it, other than to rewrite some of the first few chapters from Pitfalls of Object-Oriented Development. That was a book I wrote during my last year at Pages. We'd spent 5 years doing, professional object-oriented development back when that was something new. This is 90 to 95. And I basically wrote a book saying, here are all the things I wish I had done when we started. The interesting thing is the first 3 chapters I discovered later are pretty much universal to software development. They're not specific to object technology. And so this is why I have this, in theory, these pitfalls of modern software development. Managerial pitfalls. Using the wrong developers. Now, we've talked time and again how people are the most important factor in the success of a product. Single biggest predictor. A lot of companies don't go out and get the best people for the job. And it's not even that, we've talked about talent, skill, education, professionalism, and so on. If you try to build a project with people who aren't good at what they're doing, it will likely fail, or it will just be bad. Using the wrong metrics. We've talked about metrics. It's hard to come up with good metrics because it needs to be objective, repeatable, and automated. And if your metrics don't meet those, actually it needs to be objective, repeatable, automated, and actually tell you something meaningful. There are a lot of bad metrics used because they meet those first 3 requirements, but they don't meet the 4th. They don't actually tell you anything. Lying to yourself and others. Oh, this is so endemic in the software industry. We get back to the item that all engineers are optimists. Or as Adele Goldberg, who I quoted once, said, only optimists build complex systems. Or attempt to build them, often with failure. It's really easy to fool yourself to say, yeah, with a few extra weekends and maybe some light nights, we can get this thing back on track. Or, we're certainly going to discover that magic sauce that we need in order to actually get this algorithm to run in an acceptable time frame, as opposed to taking more than 24 hours. The problem here, this gets back to the thermocline of truth, is often as you move up chains of management, they don't want honesty. And in the end, really all you can do is be honest and back it up, and then you may have to make a decision whether you're going to stay there. Not identifying and managing risks. There are whole books on the subject. One of the best is by DeMarco and Lister, same guys who did Peopleware, called Waltzing with Bears. But again, you want to be very proactive in managing risks and saying, okay, here are all the things, and this is, again, in your weekly status reports, what are your issues and risks? What are the things that could go wrong? Are we on top of it? Are we aware of it? Are we surfacing them? If you manage risks, you may not succeed, but you won't be surprised. And you can basically take corrective action earlier and say, okay, it's pretty clear we're just not going to get this feature working. It's time to sort of mothball it, maybe save it for 2.0, and move on. Adopting a technology or methodology without well-defined objectives. Why are you using Agile? You're using Agile because you've been part of several successive Agile techniques and you have a group of individuals who know how to successfully use Agile. That's a good thing. If you're adopting Agile because your vice president of engineering read an article on Agile and decided we're going to shift over to it, no one has experience with it, that's a bad thing. Yes?
So what's the proper way to implement a change like that?
Small trial projects. In other words, that is the key question. If they say, we want to do Agile, the proper response is, sure, let's set up a small team, give them a trial project, non-critical, and let's work it and see how it works. Give them the experience. It's too often what happens is it's used as desperation. I've already mentioned before, a number of failed projects I've reviewed, after like the second slip, I'll see them adopt Agile for about 2 months. It's like, this will fix everything. And after 2 months, they abandon it because no one knows how to use it. They're not getting any benefits from it. Misjudging relative costs. Some of these I have to go back and say, okay, what exactly did I say here? Oh, insufficient time is allocated for specification, research, design, architecture, and review. That should occur before coding and during each development cycle. Likewise, software quality is given little time, money, or people. Oh man. We're back to Brooks. Brooks says half your time will be spent debugging on tests. He says no one plans for that, and that's what everyone pretty much spends their time doing. How many of you in your own projects have encountered problems that ended up soaking far more time than you expected in your projects? Yeah. And it's kind of like, why isn't this working? How many of you ran into problems with external libraries, APIs, tools, and so on, that turned out it's like, this should have just done this, I'm trying to figure out how to do this. How many of you ran into, yeah. This is what happens. You're dependent upon other people's technology, and most of them are black boxes. You have these black boxes, and you have a lot of black boxes, and they all have to work, and they don't necessarily play nice with each other. Or the documentation doesn't match the reality of what the black box does or is supposed to do. Okay, let me get back to my classes here. Allowing new features, oh sorry, that should be done there. Allowing new features to creep in or to pour in. Okay. Feature creep is a major cause. How many of you have been working on a project where you think you're actually seeing the light at the end of the tunnel, and suddenly someone in management or marketing comes back and says, oh, we need to make it do this as well. And this, and the hands go up, yes. As I've told you, I've had shouting matches over this. You told the customer what? We can't do that, Rand. We can't do it. It doesn't work. Allowing the specification to drift or change without agreement. In other words, if you have an actual specification document, here are the features, this is what it's going to do, and people go in and start editing that without everyone signing off on it. That happens. You go back to look at the document, you see it's been updated like last week, and suddenly there's 5 new features there, and you're saying, wait a second, I'm responsible for developing this. No one asked me if this is going to go in. Attempting too much, too fast, too soon. I've gone over this numerous times. This is the classic. Oh, We're going to use a new methodology, we're going to use a programming language that no one has had, and this is for a mission critical project that has to be done in 3 months. That happens all the time. Management thinks that the new technology and or methodology is going to magically allow them to, create software, high quality software in a faster period of time. Abandoning good software engineering practices. Often when there's new technology involved, and this really stems, I've told you this before, back in the early 90s there were people saying, oh, it's object-oriented development. We don't need to do software quality assurance. I was like, are you nuts? It's actually more difficult. If you structure it right, if you have test frames and frameworks, but this is early 90s, this is before you had Java. And it's before you had test frameworks and unit testing and so on. But you had people in management convinced that objects just magically worked. Okay, political pitfalls. In adopting a new technology or methodology, you want to make sure that management knows all the risks. In other words, if you're the champion and you're saying, I think we should do X, I think we should switch all our development to Go, or Swift, or Angular, or whatever the flavor of the month is. You'd better be sure that you clear it with management and that you have them on your side, because if things go wrong, guess whose neck it's going to come down on? Underestimating the resistance. Now, let's say I'm the chief technical officer in an organization and I suddenly decide that we should switch to DevOps and CI/CD. Yep, very, very good, very noble and so on. What if my developers don't want that? They're very comfortable with what they're doing now. They can sabotage you. If your developers are resisting, you have to enroll them in this shift. Remember, people hate change. So if you're changing stuff, you have to make sure that you understand who might resist it, and whether or not they're going to be overt about it or simply sabotage the project to watch you fail. That does happen. Overselling the technology or methodology. This is a thing. Oh, if we just switch to this language, everything will be wonderful. That's again why you want to do small pilot projects. You don't want to do it on mission critical. Because if you oversell the technology or the methodology, again, it's going to come back down on your head. Not recognizing the politics of architecture. We've talked about that before. Again, if I'm a chief software architect and I feel that we need to switch to a particular set of technologies to better implement it, I have to go around to all the developers and sell them. I can't just dictate it from on high. Getting religious. This is the, oh, if we just do this, if we just go to functional programming, everything will be wonderful. We'll solve all our problems. That's pretty much what we had back in the 90s with object. Oh, just switch to object technology. It'll all be wonderful. It'll all work. Everyone will become great software engineers. We won't need to test. Recognize that whatever technology or methodology you're proposing, it has its weaknesses as well as its strengths. Getting on the feature release treadmill. I don't know if I've told the story before. I went in with a team to a large financial firm that had successfully, sort of against all odds, had managed to actually meet the deadline on a 1.0 release of a newly re-engineered customer-facing website. And the response, and they incurred a lot of technical debt in the process. And the response from management was, that's great, do it again. And basically some of the higher up techs brought us in to come in and convince management, no, give them a chance to actually go back and fix things, because they're setting us up for failure. It was a miracle that we went live with as few problems as we did, but we've got a lot of cleaning up to do behind the scenes. And management now wants us to do the same schedule again. Betting the company on a given technology or methodology. In other words, yes, our whole company is going to be founded on using this particular language or this particular approach to software development. And if you don't know what you're doing, you can lose the company. Picking the wrong horse. Pages, Pages was, from a software point of view, a great success. Problem was, it was written for the next operating system. Now, when we started that in 1990, that actually seemed like a good bet. We had several other companies, major companies, that were all developing for Next OS. Problem was, the hardware, the actual Next hardware, was expensive, didn't sell much. Next went to a software-only business, and they were getting very little market penetration. We launched Pages. We sold well within the installed base, but the installed base was too small to support us and support the company. And we were desperately trying to port our technology over to Windows, and we ran out of money and closed. Now, of course, Steve then went on to sell Next to Apple about a year after we closed. We closed in 95 and 96. He sold Next to Apple for $400 million. Within a year of that, he was CEO of Apple, and Mac OS X is a direct descendant of NextStep, the operating system we developed for it. But sometimes you pick a technology or a company, and it's just wrong. Okay, yes?
How do you judge between, like, I don't know, like, so let's say you have a project and you know a certain technology is much better suited for that, but your personnel aren't skilled in that technology as the person else. How do you make the judgment between, like, having them learn and incur that overhead versus doing what they're used to doing?
That's actually a very serious problem. Now, when I hired the team, the engineering team for NextStep, there was only one developer that I hired who had prior experience with NextStep. I had prior experience with it because I'd written the next book for Addison Wesleyan. I had attended a 0.3 developer camp, and so I was very familiar with Objective-C. But there was only one programmer who also had, when I hired him, had any prior Objective-C experience, and everyone else that I hired had to learn the language, had to learn the operating system, and so on. And so I tried to pick really, really good people, and they were very successful in learning the language, learning the operating system, and everything else. We're sort of back, and I hate to sound like a broken record, but we're sort of back to the pilot project. If you have something like that you think can be successful, the ideal is to gather a small group and say, this is the language that I think we should be on in the future. Let's do a quick project, a proof of concept for the technology we're trying to develop and see how it works. And that does two things. First, it gives you some proof to take to upper management saying this will work. And second, it will let you see how well your developers are picking up the new language and then the associated concepts. The problem with that, of course, is that you're in a money-making business, and can you cut the people free for that period of time? You're sort of stuck on a railroad track, and it's kind of like, yeah, we want to move over to a different railroad track, and do we stop the train and move over there? And if so, what's going to be the impact on the bottom line of the company in the meantime?
Yeah, and I guess a follow-up question, like, what are the advantages of, I guess, like, hiring new people who are experts in that technology versus training?
The advantage of hiring people who have existing skills in that technology, is that hopefully, if they're good at it, they've already learned the pitfalls. They don't have to relearn all the problems. Back when I was learning C++, there were a couple of great books. Oh, what's the author's name? Called Effective C++ and More Effective C++. And what it was basically, here are idioms and techniques for programming C++, things you should or shouldn't do. If you hire someone with experience in that, then they know already that they've They know what to do and what not to do. Learning something new, a new technology, you have to go through that curve. And they have to sort of, unless you've got some sort of basis where you can actually mentor them and train them, you've got to go through that. If they're really good, really smart developers, they'll pick it up. I have to pick up new technology all the time as an expert witness. And I always feel a bit lost and over my head at first, and then I just sort of find something, I find a thread I can grab onto, and I start pulling through. It's, oh, this does this, and this does this. There are times, and I say this with really all true modesty, I've gone back and looked at some of my expert reports and said, how did I ever figure that out? I testified in a patent case that had to do with medical devices that inject MRI fluid, or not MRI. Basically injects fluid for doing scans on people. And the software code that I had to examine was an H11 microprocessor, all in assembly language, using hardware I/O, so reading and writing data at specific memory locations to communicate with the hardware device. And I remember at the start of that feeling like, oh crap. I've got to figure out, I've got to learn to read this particular assembly language code. I've got to figure out what these memory addresses are, what they are. And by the time I was done, I knew it cold. And testified very successfully at trial. So that's a problem. So thinking it comes for free, thinking it will solve all your problems. Every technology, every methodology will have its strengths and weaknesses. It's going to take ramp-up time. It's not going to solve all your problems because, frankly, most of the problems you have, well, in fact, let me click through on this one. Here we go. Here, what it takes to create software. You have to be aware of and identify the problem, decide to solve it, decide the resources you have, securing and managing those resources, defining the scope, analyzing, defining the problem, defining the solution, designing the solution, implementing, testing, verifying it, delivering the solution, modifying it, and so on. Now the question here, how many of these activities will the new technology or management actually affect? I would say probably at least 70% of these are independent of your technology or management. So accepting it, you still have to deal with all of these. It's not going to magically make you a better analyst. It's not going to magically allow you to do that discovery or invention any quicker. Well, actually, it might help a little bit. So that's a problem. The last few here, how many of you see, what are some of the current technology buzzwords that you see on Twitter or places like that? Machine learning. Huh? Blockchain. Cloud computing, AI. I have a little meme that I use regularly that says, there is no cloud, it's just someone else's computer. I have a meme that I actually created. Did I already show you that one? My AI meme? Yeah. I use that on a regular basis. But this is what happens. Management hears this, and industry sells it based on that. We've got, I get my Twitter feed is filled with books and conferences and companies all talking about machine learning. And machine learning is great. It really is. But it's not a panacea. It doesn't apply everywhere. And it becomes an issue of hype. So you've got like confusing tools with principles. I use an object, I use an object-oriented language, therefore I'm an object-oriented developer. No, well, I can be a real crappy developer using an object-oriented language. There's a lot of crappy, not well-designed object-oriented code that's written in object-oriented languages. Confusing training with skill. We send all our developers. We're gonna switch to Go. We're gonna send all of the developers to a week-long training conference on Go, and hey, they'll all come back experts. I mean, I already told you the case at Eric where the developers had gone to a week-long training on ASN.1, and that was their entire experience with it. And they were supposed to develop this software on a very accelerated time schedule. Confusing prototypes with finished products, we've talked about that. Confusing approach with results, in other words, saying that I am doing functional programming doesn't mean that actually the software I write ends up to adhere to best practices of functional programming. It's amazing. How many of you have read really bad source code? Oh, no. And guess what? Did you look, now, lift your hands again. Now look around the room. Now does this give you an idea of how much bad source code there is out there in production? It's a tremendous amount of bad source code. You know, Jerry Weinberg says if architects built buildings the way developers build software, the first woodpecker that came along would destroy civilization. It is a testament to how adaptive organizations are around their bad software that the world functions as well as it does with a lot of really bad software out there. Asking the wrong questions. And I'm clicking on this because I remember what this was. Oh yes. These two questions. The whiskey question. Why isn't someone coding yet? We've got this project. Why isn't someone coding it? Now, if you're doing a CI/CD or an agile thing, it's like, yeah, we design a little, we code a little, and so on. But often what they really mean is we expect to be done. We haven't finished analysis. We don't know what we're building. We haven't analyzed our target market. And then the second question is, when will the program ship? Now, the problem, as I say here, those aren't bad questions, but if that's all you focus on, it distorts the software development process. And you end up with bad code. Sometimes you end up with bad code anyway. Okay, so that's it. As you probably got a sense, by the way, Webster 7 is a great source for the midterm. There's a good chance for just about any question you have there, you can look through those lists and say, oh yeah, this seems to apply. Now, Webster 7, asking the wrong questions or whatever. Here is the rest of the semester. You have a stats report, whoops, come back here. You have a stats report and a podcast. I think that's your last podcast. And next to the last status report. Due Saturday. Midterm. Do you want me to go through the midterm review again? The slides are online. The video's online. Go back and look at those. The Monday after Thanksgiving, my daughter Chris Vivian will come in and tell you what it's like to be out there in the real world. She's been out there for about 4 years now, and she is remarkably frank as far as the problems she's encountered, and she's entertaining. And I think she's gorgeous, but you know, that's me. On the 9th, I will give a lecture on legal issues in IT, basically things that you need to know about and avoid. And we'll cover Webster 8, which is the white paper I did at PricewaterhouseCoopers on patterns in IT systems litigation, or system failure litigation. And then the 16th is your business pitch and final demos. It's a cutoff for all makeup. So if you have stuff you need to watch to get attendance in there, and by the way, by next Monday I'll try to have an updated attendance score, so if you've actually missed classes, you'll see that reflected in your grade. Have fun. But if you haven't necessarily made everything up, you'll see that reflected too. Yeah.
So with the midterm, is it only available at 11:25?
Yep.
On Monday?
Yep. 24-hour period. So, yes,
Just to clarify, will there be class next Monday? Or
No, no class.
Okay, cool.
no, I won't be here, and there's only a few outlets here, so I suggest you find somewhere better. Yeah,
Quick question, so the 16th is listed as a final exam day in the university schedule? It says that the last day of classes is like 3 days prior.
Yeah, the 13th or 12.
So,
well, in that case, I'm off on a schedule here. If that, and I'm not doubting you, let's see here. I didn't go back and look at my own class schedule.
And it's that Thursday or whatever's the last day of last.
No, so it looks like it's gonna be Chris and legal issues. So I'm wrong. I should have looked closely. I added a week there. Everyone's like, hey, wait, this is too long. Okay. And this will be thank you for catching that. That's what I get for making this up without double checking. There we go. There's your schedule. My gosh, we're almost done, aren't we? Midterm and 2 classes. Any other questions? Guys did great on the demos. I apologize for the problems with Linux and Mac systems. And good luck on the midterm.